Thank you. Indeed, welcome to the presentation with the longest title ever. I'm Adam.
And I'm Amir. We're both from Intel. Okay, start. So 4 years ago, I joined Intel's Wi-Fi organization to head a new software architecture team. And I found an organization in the midst of a crisis. We're just after a series of reorganizations, how fun, and with a new management team, having very little trust from the engineers. And we're having also a technical debt that, to put it mildly, it was challenging. And if this wasn't enough, we were now facing what seemed like a roadmap explosion. We were asked to expand our Wi-Fi chipset portfolio to new markets and to start support new OSs, each with its own flavor of Wi-Fi software architecture stack. So the reorg merged 3 different groups located in 3 sites to one big 150 software developers group developing low-level software. I mean, embedded firmware to drivers for each one of the OSs that we support. We were developing Wi-Fi for about 10 years. So you can imagine that we had quite a lot of sustaining work to do for existing products, but also quite a lot of legacy code around, which explained the technical debt. And when I established the team, there was no formal role for software architects in the organization. There were only senior leads in the teams, but none of them was responsible for the entire software solution. We also didn't have any practices, well-established processes for software architecture, and even little software architecture documentation. So how did we get out of this crisis? Well, quite easily. I just dialed 1-800-architects and called the superhero architects to save us. You know them, huh? Yeah, they're great. They come, they just remove all the muds, they restructure their architecture to support product lines, and I had only to lean back and watch them refactoring everything, and they even write documentation. Wow. Well, yeah, unfortunately it wasn't the case. As you can see, Adam doesn't have any superpowers. In fact, we're facing an organization made of silos that doesn't trust these new architects, or at least they don't have a clue how we're supposed to help them. They were struggling to get the next release out of the door, and were actually quite frustrated from the fact that management has decided to deal with architecture now, instead of having all these smart people going into the lab and helping with the debug. So what I realized then, that even if I had those superhero architects, they would still struggle with silos, with lack of collaboration, with the lack of trust. So instead of having superhero architects, I rather need architects that are going to be some sort of superglue. So 4 years later, Adam is a leading architect in the team, and myself are here to share with you today what we see as a key ingredient in successful software architecture teams, which is the social function that architects play in their organization, in addition to just providing the solutions. We're going to share with you our stories, what worked for us, where we failed, and how we contributed to getting out of the crisis.
So before we continue with our story, I want to tell you about a book I read. It's called *Sapiens* by Yuval Noah Harari. Anyone know it? Anyone read it? Well, you don't have to be a big history buff to like this book. It's really good. And the reason I'm telling you about this book is because it makes a really interesting argument. It says that our species, Homo sapiens, is the most successful species on Earth. After all, we've started out more than 1 million years ago, just another type of animal. And today we've evolved. We've spread everywhere across the world. We're at the top of the food chain, and there's over 7 billion of us. And the interesting question that rises in the book is, why us? What makes us our species so unique that allowed us to become rulers of the Earth? And why am I telling you about this? Well, software apparently is written by Homo sapiens. And to have big pieces of software, we need big groups to be able to collaborate. And it seems that as a species, we've mastered this ability to scale. And if we can learn how we did that, maybe we can learn how we can scale our software architectures. So humans are classified as social animals. This means even software people are social animals, or most of us. And if I'm a social animal, then my success, my survival depends on my ability to function within my group. This means that I need to look at my group and understand who's who's someone good that I can be friends with, who I should avoid because he's an enemy with someone else. And biologists found that groups of social mammals have a limit to their size. It's about 50 individuals. The reason being that if I'm a member of a group of 50, it gets really hard for me to observe and understand everything that's going around me. And we as a species were able to go beyond that. We were able to create bigger and stable groups. And we were able to do that by using our language. Now, we didn't invent language. Other animals have languages as well. We just started using it in a strange new way. We started to gossip. I know it sounds strange. This is true. But it sounds strange. But gossip, if you think what it is, it's the exchange of information about interactions between individuals in a group. And it seems that by gossiping, we were able to communicate to each other social information much more efficiently. And we didn't have to spend so much time understanding our group. And we were able to scale. And we got to around 150. This limit for the new groups of people comes from the fact that our brain has a capacity to maintain about 150 stable relationships. But we were able to go beyond that. Consider us here. Most of us have never met each other before, yet we are still able to collaborate. We can have a civilized discussion on the same topic, and we are able to do this because of our ability to tell myths or imagined realities. Imagined realities, we'll call them myths for the sake of simplicity. They're objects or entities that don't exist in our objective reality. They are imagined, but we imagine them together. And we agree that for us, they exist. And based on this agreement, we collaborate. So we're here because long ago, our forefathers created a myth. They called it software architecture. And it's really a myth. I mean, I cannot take it out of my pocket and say, here, take my software architecture. I can't say that yesterday by the river, a big software architecture was running after me. But we are here, we are collaborating based on this and based on other myths as well. I mean, if we think of us as humans, we collaborate based on money, based on the notion of a conference, based on things like laws and government. And all of these are myths. And the interesting thing about myths is that they allow also for very fast change to be made. Let's say we would have a fire drill. So at the sound of an alarm, everyone would get up and leave the room. Now, this is a huge change in the dynamics. And it's not because there is some fire that chases us away. It's because we agree to imagine it together.
So when Adam shared these ideas with me, I was thinking, how come he has time to read history books? We're in the middle of a crisis. But thinking about it some more time, I actually figured that this explains quite nicely the notion of the superglue architect that has these two types of glue, the gossip glue and the myth glue, and he knows when and where to apply them. So next we're going to discuss each one of these glue types and to share with you our stories. So let's start with gossip. As Adam described it, gossip is an efficient way to communicate the information about the people in the group, and that allows us to overcome this boundary of about 50. And if you remember our story, we were 3 groups of roughly 50 engineers merged to 150 engineers. And I remember I was traveling to one of our sites, talking with one of the senior engineers, and he was starting to complain about those folks in the other site, and they were sabotaging his software. They were starting to introduce new infrastructures that he thought that were already there.
So if Amir's story sounds strange to you, I'm guessing you're a software architect working in a very small team. If that's the case, lucky for you, because small teams tend to communicate very efficiently. Even if there are disagreements, eventually a decision is made, and the team moves as a whole and can change if it's needed. This was very far from our reality. Anyone here heard of Conway's Law? Come on. No software representation is good without mentioning it at least once. This was exactly what happened to us. Conway's Law says that organizations will create systems that reflect their communication structure. We had 3 groups, each of the group maintaining their own part of the system, of the software, and these components of the software talk to each other just like the group, very badly. And I remember I found myself most of the time back then going between the groups and communicating to them what's going on in other groups, what they should share, what they could share. Maybe we should have common infrastructures. And over time, people started doing this. They started gossiping more about software and talking to each other. And once they started doing this, they started making better architectural decisions. And we then realized that as architects, we should continuously foster this software gossip to be more resilient to Conway's Law and to have a more harmonized architecture.
As a team of software architects, we are actually positioned in quite a unique place in the organization that allows us to see the entire software solution. So we can be those who can foster and facilitate the software gossip. But not only when being asked or approached, but to actually proactively initiate it. So what do we consider as software gossip? Well, it can be any topic that can help an engineer working on one part of the system to be familiar, to get to know other parts of the system that he usually doesn't work with. It This can be discussions about architecture and designs of other parts of the system. In our case, we shared the firmware architecture with the driver groups, which really helped in the later integrations. Or it can be sharing lessons that were learned in other groups, or even spreading the word about code that could be reused, or to encourage creation of common infrastructures. And I think that also the fact that I'm part of the management team, and we're a small team of architects that cover the entire software, it allows us, and we meet with both managers and with the developers, it allows us together to efficiently collect this software gossip from around the organization, and to work together and to figure where we need to spread it. And this brings me to the idea of the networked organization, which also mentioned a bit before. So we're all to typically think of our organization with the hierarchical org chart in mind. But if I will urge you now to take for a moment the red pill and think of the organization through the eyes of the social connection between people. And you will see a different structure emerges, which doesn't necessarily align with the org structure. You see people that have a lot of impact and influence, which doesn't necessarily have a formal role. You know them. These are the go-to people that you need to talk with in order to get things moving. So networked organization with links between individuals that crosses organizational boundaries, that crosses disciplines, that crosses even management levels, are organizations that can move much faster, because the network compensates for the fact that the hierarchical structure, especially in big organizations, tends to be quite rigid and even resist to change. So it allows us to be much more dynamic and much more adaptive. And I relate the fact that, I relate the ability to create those links between individuals to the amount of software gossip that we have in the organization. So if I'm, as an architect, create and foster this gossip and create those links and bring together people and ideas, I can build a much stronger network inside the organization. So to conclude, while the word gossip, yes, it may have a bad connotation, but just keep in mind it's only a metaphor. It allows us to communicate much more efficiently. And it's quite easy to see when it's missing. You see Conway's law much more evident. You see teams that bend their designs just in order to avoid talking with some other team they don't know, or they're not aware of what they're doing. And you see a lot of duplications, lack of reuse because people are not communicating, or lack of awareness. And I think it is the architect's role to be the one that fosters and facilitates proactively this software gossip around the organization, especially by provoking discussions, to have good software discussions, but also to make those human links.
So our next type of glue, or myths, we talked about the fact that when people imagine things together, they are capable of collaboration and making changes at massive scales. And in software, our myths are usually the things that we don't see in the code. The most common myth usually is the blueprint of a system, or the system, or the architectural diagram. And it should be general enough so that anyone that writes code in the system can point at the map and say where that code goes. And once we have this blueprint, once we have an architectural diagram, we can start talking about the different abstractions that are related or are derived from the diagram. We can talk about layers. We can talk about services. We can talk about any view that shows us some aspect of the system that is basically an abstraction. And these myths allow us to rationalize about massive amounts of code without really having to get into the details. Another type of myth is the technical decisions and the architectural and design guidelines we make along the way. These guidelines and these decisions together start building up towards a new myth, which is our vision for the system. This is a very important myth. It eventually allows us to lead people in the same direction and even change direction in case we need to. So you can see that the myths are basically the most important artifacts that the architect creates. The architect builds those myths, maintains them, and he spreads them. And when I write an architectural spec, I fill it with lots of myths. I put static views and dynamic views, all the different quality attributes and the rationale behind them. But the interesting thing is that not only architects are the ones that should create myths. I remember that I was leading the architecture of a system that had a lot of legacy code. And there was very little documentation. So practically, there wasn't anyone you could find that could understand the entire system. So I set out to try and weed out from the code the existing myths. And together with a group of leading developers, we had a set of discussions. And we talked about what we think are the existing guidelines in the code, what guided whoever wrote the code, and what was the vision back then. And the result was a set of really passionate discussions, a set of retrospectives that allowed us to define and decide which are the myths that we like and which are the myths that we think are creating a very weak system. And we should change those myths for something new. So, how do you create good myths? First and foremost, a myth needs to be simple. It sounds trivial, but if your architectural diagram is too detailed, if and has too many things to see, and your design guideline is too specific, it will be very hard for people to remember it. A good myth needs to be catchy, like a radio commercial that sticks in your head. A myth also has to be abstract. It needs to hide away details that only few people know or understand. This allows us to get more people to relate to the myth, because an abstraction is something that others can understand much easier. At the same time that a myth is simple and abstract, it needs to be close to reality. It sounds contradicting, but it really isn't. It means that we have to use abstractions that people are able to connect to the code. So we have a couple of ways to do this. First of all, you should make sure you use examples of your abstractions. What in the code is an example for this abstraction? And the other thing, never use terminology that you don't properly define. So don't go talking about components before you tie them to some tangible part of the code. And everyone understands components differently. And once we define them well, we can use them in our myths. Last but not least, a myth has to come with rationale. Giving the why for creating a myth is more important because it allows people to connect to it. And aside from that, remembering the rationale for a myth is something that allows us to revisit it over time. Because conditions change, things change, and sometimes the reason why we created a myth are no longer relevant. So we might need to change it.
So one of the software architecture changes that we were driving was the implementation of software product lines. We call it core product separation, meaning to separate our core business logic from all the product-specific, hardware-dependent code that we have. And we thought it's a simple myth to tell, but we figured that for many of the developers, it was too abstract, and they couldn't connect it with the actual pieces of code. And they were right, because in different domains, you could apply different strategies to achieve it. So we figured that we need to close this gap. And we provided better guidelines, but more importantly, we provided rationale that could really help the developers to select between those different patterns or different strategies in order to apply this architecture. So, how do you spread myths? If you think that after you wrote an architecture spec and sent it in email, your myth spreading work is done, you're probably wrong. Trust me, we tried it. We failed. We wrote a very nice spec, reviewed it with all the key stakeholders, and yet in the coming weeks, people just kept designing with the old architecture in mind. The organization was big, and we didn't get to everyone. So myths should be told near campfires, to small teams, again and again. And when we figured that, we started a roadshow. We traveled to each and every site. We met with small teams. We were providing much more context to the architecture, to the myth. And we even told the myth in the local language. And the result was, when questions came up, we could get into the next level of details, and teams were becoming much more collaborative and engaged. For a myth to successfully spread, it needs to become canonical enough so that other people in the organization start telling the myth by themselves. And you know that this works, the myth is spreading, when you just start hear it resonating around you. So do you know these annoying people that leave meeting rooms without wiping the whiteboards? Well, sometimes I was quite happy about it, because when I entered this meeting room, I looked at the whiteboard and I saw there the exact same architecture diagram that I've created. So I know that the myth is now spreading. Or when I'm attending a meeting and I'm hearing the new terminology that the architecture introduced, now used by the members of the group, then again, I know that the myth is now successfully spread.
So before you go out and start spreading your own myths, make sure you understand first what are the existing myths in the organization. They might not align and may even compete with your own myths. I remember that I was looking at the system and I saw that in some areas of the system we were spending far too much time debugging and sorting out issues. And this seemed to be because of high levels of complexity. So I set out a new guideline, a new mini-myth, that in these specific hot zones, as we call them, we should emphasize code readability, and we should add more debug information, even at the cost of a bit more memory. And the thing is, for years, our organization was writing low-level embedded software for systems where memory comes at a very high cost. And people were getting into the habit of reducing their code size as much as they could, sometimes even rewriting the code so that it takes a smaller memory footprint. And this was eventually a competing myth, because it completely confused people when I was advocating to add more memory for the sake of debug. So when you understand you have a competing myth, try to look around and see who are the existing myth tellers. In our case, we had an amazing software guru. People would come over to his site from all other sites just so they could together sit and reduce their code size. And when I realized that, I made the trip as well to his site. And we had a pretty nice talk about what we think are the areas that we should save on memory in the system, and what areas we think are more error-prone, and we should add more debug information. And the result was a unified myth that both he and I were telling about where the system we should make sure that we reduce code, and where in the system we should invest code for the sake of the entire system. So let's summarize myths. Myths also, like gossip, they have a negative connotation. Think of the Mythbusters, for example. But we need to remember that as a species, we need myths to be able to imagine together things and to build together big things. And the ability to tell a story that connects an entire organization is a crucial skill for a software architect. It's also easy to see when you don't have myths, or when myths are different. So you can see that, especially in multi-site companies, depending on which site you are, you will see a different view of the system. You might see completely different diagrams of the same system. Sometimes it's even worse. There is no one canonical diagram, and so each person has his own private vision of the system. And this usually leads to lack of coherent design, lack of conceptual integrity of the system. Even funnier are cases when the myths have gone wrong. Consider that if you don't maintain a myth with its rationale, over time, the myth may become irrelevant. It may become obsolete. And these times, you will get myths that are blindly followed. People act upon the myth, but they don't remember why or if it should be still relevant. And in these cases, the architect first has to be a myth buster before he can start spreading his own new myths.
So when you're trying to get out of a crisis, it's many times not easy to stop dealing only with the short-term issues, with the firefighting, and start to look for bigger long-term changes that needs to be made. And software architecture changes are difficult because they take time, and they engage many people, especially in big organizations. They cross disciplines. So it's hard to drive them even if you have the right solution at hand. So just architecting the right solution, in many cases, won't be good enough.
So we've shared to you today our two types of glue that we use in our work. We talked about the gossip glue, which we want to proactively foster to have an organization that is more resilient to Conway's law. And we talked about the myth glue, which we as architects, we create, we spread, and we maintain them. And the myth glue is very important because an organization with good myths and good myth tellers is a strong organization, built of people that can move together, sharing a common vision, and even change course if they need to. But don't be mistaken. Gluing cannot be your only role as an architect. If you cannot come up with good technical solutions and make strong decisions, you will be irrelevant. But we have seen the other extreme as well, where we have very strong technical leaders that don't use either of these types of glue. They don't have them in their toolbox, and they become irrelevant as well.
So 4 years later, we got out of the crisis. We successfully delivered all the software to all the different programs on the roadmap with roughly the same headcount. So obviously, our small team cannot take all the credit, but I can humbly say that we played an important role in the success.
So before you go, Amir and I would like to encourage you to think about your organizations. Do you think they are gossiping enough? Do you think you have myths and myth tellers? Do these myths align? Do they compete with each other? We'll be here for the rest of the conference, and we'd very much love to hear from you.
Thank you.